All right, so this is chapter 1.7, section 7, modeling with quadratic functions. We've been talking about how to build quadratics for a while. So to this chapter, this section, what they're really doing is they are starting to mix in more exponentials, more not logarithms, linears, so that you can start to distinguish one from another, that you need to start distinguishing between the three. You also, how do we make something quadratic? So if they give you a set of data that really doesn't fit anything, but they want to say, hey, make a quadratic model, how do we go about doing that? What do we average in order to do that? So I'm going to slide on down to a different page real quick. Okay, so on example 1, I think it's on page 96, but you can scoot on down, find example 1. And it states a ball is thrown from the top of a building. The table below shows the height of the ball above the ground at 1 second intervals. Determine whether the set of data represents linear, quadratic, or exponential functions. So we're basically going to start running it through the paces. See, remember linear, with linear, the first difference is the same. With quadratic, you're still adding and subtracting, but the second difference is the same. With an exponential, we're no longer adding or subtracting. Remember, we're dividing 1 by the previous. So like divide 105.1 divided by the 100 above it. So for an exponential, the ratios, ratios, are the same. So that's what we're looking for. So we're going to figure out which one this is, and then we're going to go from there. So I'm going to first find out the differences. So 105.1 minus 100, that's 5.1. And then we'll keep on subtracting. 100.4 minus 105.1 is negative, I think, 4.7. And I'm going to pause and put these up there right quick. Okay, so those are the linears. I mean, those are the first difference. And hopefully you see instantly that this is not linear, because in no way, shape, or form is the first difference the same. So let's go and do the second difference. And we'll type in our calculator. Get the right pencil. Negative 4.7 minus 5.1. So negative 4.7 minus, helps me do it right, negative 4.7 minus 5.1. And you get negative 9.8. Negative 9.8. And do it again. Type it in negative 14.5 minus negative 4.7. And you get, oh wow, we get negative 9.8 again. All right, and keep on going. I'll put them in real quick. And you realize that based upon the second difference, since that's the same, this is quadratic. All right, so all of them are negative 9.8. My second difference is 9.8. So we just need to find our A, B, and C values. So for this case, A, remember, is the second difference divided by 2. So A equals negative 9.8 divided by 2, which I think is negative 4.9. 9.8 divided by 2. Yep, negative 4.9. Your B value is your very first difference, which, again, between your starting point and the next point, so your very first difference with this one is 5.1 minus A, so 5.1 minus A, so minus negative 4.9. So 5.1 minus negative 4.9, I think that's what, 11? Nope, it's 10. I was off. 10. And then C is your starting point, which in this case, when X is 0, Y is 100. So my starting point is 100. So here's your equation. I'll write it over here on the left. Y equals negative 4.9x squared plus 10x plus 100. And that will give us this set of data, verbatim. All right. If I were you, if you're feeling brave enough, go try example 2, see what you can do with it, and we'll go from there. All right. Actually, I know I said example 2. What I meant was you try it, number 1. I apologize. We'll do example 2 in the next video. Come on. There we go. So a softball pitcher throws a ball to a catcher. The ball's path is tracked in the table. Determine whether the relationship is linear, exponential, or quadratic. So we got to figure out which one it is, and we'll write the equation. I know it doesn't say write the equation, but I want you to. That is part of what I want you to do. The equation is where we're headed. So we'll start off by finding the difference. 5.6 minus 2, 543, that's 3.6. 8.4 minus 5.6, and I'll just pause and do that. And those are your first differences. And hopefully you realize really quick that, again, this is not linear. They are very different from each other. They range from 3.3 all the way down to 0.4. So let's find our second difference. So 2.8 minus 3.3 minus 3.3, that is negative 0.5. Negative 0.5. 2 minus 2.8 is negative 0.8. 0.4 minus 1.2 is again negative 0.8. Did I type that right? Oh, that's not 3.3. That's 3.6. So 2.8, so that makes that negative 0.8. That's negative 0.8. And I forgot to do this one right here. 1.2 minus 2 is negative 0.8. So my second difference all the way down the board is negative 0.8. Therefore, this is still quadratic. All right, so your A value. Second difference divided by 2. So A equals negative 0.8 divided by 2, which is negative 0.4. Your B value is your first difference, which, again, your starting point to your first point. That's your first difference. So 3.6 minus A. So 3.6 minus negative 0.4, which negative minus negative. If you subtract a negative, you're really adding. So 3.6 plus 0.4 equals 4. Now, last but not least, C is your starting point. So when x is 0, y is 2. So y equals negative 0.4x squared plus 4x plus 2. I just plugged in my A, my B, and my C. And there you go. All right.